In this video, we're going to do two more examples in which we apply the length of a line segment formula. So example 1 says find the length of line segment AB. First thing I need to do is to get the points of A and B. So B is the point, 5, negative 2, and A is the point, negative 12, 7. So one thing I do recommend is always write out the formula. This is a really good passive memorization technique because by writing it out every time, you'll just memorize it. Takes a little bit more time, but pays off in the long run. So for the x's, I'm going to take the rightmost point, which is 5, so the square root of 5 minus, and then negative 12, and that's going to be all squared, plus, I'm going to take the highest point, which is 7, minus 2, the other point, that's all squared, so I'm going to have the square root of 5 plus 12 squared plus 7 plus 2 squared, which is the square root of 17 squared plus 9 squared, which is the square root of 289, I believe, plus 81, which is going to give me the square root of 370, I believe, and that's approximately equal to 19.235. If you're ever not sure how many decimal places to take it to, 3 is a good bet. Okay, let's do the next problem. So this one I don't have a graph. Now I could sketch it, but remember, the order of the points we use doesn't matter. So first thing I'm going to do is I'm going to write out the formula. So the length, actually first thing is give these points values. So I'm going to call this W, which is 6, negative 4, and G, which is negative 3, 5. So WG is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared, which is the square root of, and let's just go negative 3 minus 6 squared plus 5 minus 4 squared, which is the square root of negative 9 squared plus, oh, just a bracket there, 9 squared, which is the square root of 81 plus 81, which is the square root of 162, which is approximately equal to 12.727, actually 728 if we round correctly. And we're done. Okay, I hope those two examples helped.